Good evening. Today we are going to discuss about the topic methods for determining polymer-polymer miscibility. There are several experimental methods to estimate polymer-polymer miscibility such as heat of mixing measurements, inverse gas chromatography, solvent vapor absorption, etc. But here we are going to focus on inverse gas chromatography. Inverse gas chromatography, it has become an accurate and a reliable and fast method for determining the physiochemical characterization of polymers and their blends, their fibers, modified silica and other surfaces. Surfactants, as well as it can be used for the commercial stationary phases and their mixtures and petroleum pitchers, heavy residues of oil distillation. Inverse gas chromatography is a powerful and sensitive analytical technique that can be used for small molecule probes for providing the information about their surface properties of the solids. And given below is a schematic diagram of inverse gas chromatography, and compared to that there's a peak that we can obtaining from it. Conventional gas liquid chromatography, that is GLC, determines the retention volume of an unknown sample in the moving phase with a non-stationary phase. The inverse method, IGC, can be determined by the property of the stationary phase with the help of the non-volatile solute which is in a moving phase. The volatile molecules are considered or designated as probe molecules. In case of the polymer blends, the probe or the volatile molecules can be swept through the column very faster and thereby according to the rule of mixtures, and if there is a strong interaction exists between the considered polymers. Inverse, the name, comes from the fact that a test material or the polymer is in a stationary phase while the probe or the solvent or the volatile molecules is injected into the carrier gas. The inverse gas chromatography, it actually has been used to investigate interactions between the probe, typically a small volatile molecule, and a liquid immobile phase like a long chain alkane. Thereby, by using this method, it is used for the investigation of interaction between a probe and a polymer, and also used for the investigation of the interaction between a polymer and a polymer. Consider that there is an inert carrier gas which is a volatile probe is present in a small concentration as a vapor, and an immobilable polymer liquid phase is coated on the inert support. Then we can calculate the interaction parameter X12 at infinite dilution between the vapor probe and the immobile polymer phase by the given below equation. That is, X12 is equal to ln 273.3 RV2 divided by P10 Vg0 V1 minus 1 minus V1 by V2 minus P10 divided by RT into V11 minus V1. Here V1 and V2 are specific volume and molar volume of the polymer. T is the absolute temperature, and P10 is the vapor pressure of the probe present in the column, and Vg0 is a specific retention volume of the probe, and B11 is a second virial coefficient in the vapor phase. And by using this inverse gas chromatographic method, the specific retention volume can be experimentally important variable, and the calculated value will be equal to the volume of the inert gas, and it is measured at 273.2 degree Kelvin and corrected for column pressure drop, and which can be eluted the vapor probe from the column containing 1 gram of stationary phase at a temperature T. So from the above mentioned equation of X12, it enables the calculation for X12 and X13, and in this type of way the interaction parameter between the probe and the polymer blend, that is X123, can be calculated, and it is shown as in the listed equation. That is, X123 is equal to 273.3 R into W2 V2 plus W3 V3 divided by Vg0 P10 V1 minus 1 minus V1 by V2 phi 2 minus 1 minus V1 by V3 phi 3 minus P10 V11 minus V1 divided by RT. Here W1 and W2 and W3 are represented as weight fractions of the polymers 2 and 3. So the polymer interaction parameter, that is X23 for the polymer blend, can be calculated by the below equation, that is X12 equal to ln 273.3 RV2 divided by P10 Vg0 V1 minus 1 minus V1 by V2 minus P10 by RT into B11 minus V1. And we already know that what are V1 and V2, what is B11, we are already stated in the above equations. So this is all about inverse gas chromatographic technique. Thank you.